Hello everyone, how are you doing? I trust you are all doing great. James from JT Smith Tutoring here. Today we are continuing with solving matrix equations, and we are going to take advantage of a question that we have already looked at before, but today we're just going to make it more compact. All right, let's get going. So this is the equation that has been given to us. They want us to solve for x, but first things first, let us take you through matrix identity, inverse, and transpose properties first, because that's what you need to be able to solve this. All right, matrix identity. When you multiply matrix by an identity matrix or vice versa, you actually arrive at that very same matrix. So remember what one does in arithmetic. You multiply one by anything or anything by one, you're going to arrive at one. So the matrix identity is a very special type of matrix in matrix algebra, and it actually assumes the very same role that one does in real arithmetic. All right, let's look at inverse properties. You take the inverse of an inverse, you actually arrive at the original matrix. You multiply an inverse with the matrix, you arrive at the identity matrix. You multiply a matrix with its inverse, you arrive at the identity matrix. You take the inverse of a matrix that has been raised to the power n, is just assume inverse and raise it to the power n. You take the inverse of a matrix that has been obtained by multiplying it with a scalar, is just as good as multiplying the reciprocal of that scalar with the inverse of that matrix. You take the inverse of a product of matrices is just as good as getting the product of those individual inverses, but in reverse order. The inverse of an identity matrix is an identity matrix. The determinant of the inverse of a matrix is just equal to 1 over the determinant of that matrix. All right, beautiful. Let's look at the transpose properties. You take the transpose of a transpose, you arrive at the original matrix. You take the transpose of a sum of matrix, it's just as good as getting the sum of those individual transposes. Okay, beautiful. You take the transpose of a difference of matrices, is just as good as taking the difference of the transpose of those matrices. Okay, beautiful. Now, you take the transpose of a matrix that has been multiplied by a scalar, is just as good as multiplying that very same transpose by the scalar. Okay, you take the transpose of a product of matrices, is just as good as taking the product of the individual transposes, but in reverse order. You take the inverse of the transpose of a matrix, is just as good as taking the transpose of the inverse of that matrix. You take the transpose of an identity matrix, is just as good as arriving at the original matrix, which is the identity matrix. The determinant of the transpose of a matrix is equal to the determinant of that matrix. All right, let's get going. Right, subtract b on both sides and take the transpose on both sides. So this is exactly what we have right here. And we know that taking the transpose of a transpose, it's actually going to yield the original matrix, which is what we have right here. This is what we have right here. We have taken the transpose of the differences of two matrices. So the transpose of a transpose here, it's going to give us A. And we want it to be left with only this part, which I'm highlighting here. I'm going to multiply both sides by the inverse of B and the inverse of A, and it has to be in the very same order, because remember, matrix multiplication is not commutative in general. This is what I have right here. So I know that if you multiply a matrix with its inverse, is going to yield an identity matrix. So this is going to give us an identity matrix. No, not this part here. It's going to give us an identity matrix. This part here is going to give us an identity matrix. So boom, I have it like this right here. So I can actually simplify this part here and then add the identity matrix on both sides. So I know if I simplify this part here, so we're going to take the transpose of a transpose, that you're going to give us an X, and the transpose of an identity matrix is the identity matrix itself. Boom, beautiful. There we are. So this is what is going to be my final answer. All right, I've got two alternative solutions right here with me. So let's quickly go through them. Okay, this time around, I decided to substitute using that property of transposes of taking the transpose of a product of matrices. So remember, if you have a B as a product and take the transpose, is just going to be B transpose A transpose. It is the product of the individual transposes, but in the reverse order. This is exactly what you're seeing. You see right here. So the A is what we have right here. So beautiful. Okay, we are right here. So I'm gonna take the inverse of the transpose. You can see what I'm doing here. Those whatever I do on the left-hand side, that's exactly what I must do on the right-hand side because this is an equation. It must be balanced. All right, beautiful. So I have this right here, which is what I have on my left-hand side, and the right distributed this. This is what you're seeing. So this multiplied by that is going to give me an identity matrix, but also multiplied by that, this is what we have right here. Okay, minus you left distribute this inside here, and then you right distribute inside here. This is exactly what you see right here. This because this is what is common to both sides here, but I decided not to. All right. Then adding my I, this is what I'm gonna get right here. So this whole expression is going to be, you know, like what we have right here. Then obviously I need to have my X right here. So it's gonna take the transpose of a transpose. You arrive at the original matrix. This is what you have right here. Boom. They had to take the transposes of this. Actually, it's a simplification of this whole thing. Did you see that, Jimmy? It's giving me exactly what I had right here. Okay, so your way of actually representing the final whatever, it might be different, but if that expression is actually simplified, it must boil down to the very same expression. Wonderful. Right, here is another alternative solution. What I did was to first simplify the expression in the innermost term. So I could have simplified right here. Take transposes. This time around, I did not even subtract the b yet. So I'm taking my transpose. Okay, beautiful. This is what I have right here. And you take the transpose of this. This is what you're going to get. For me to be only left with this part here, I'm going to multiply it with the inverse of b and the inverse of a. And it has to be done throughout every term. Okay, beautiful. So I would like to believe that I've already given you enough arsenal and you know how to move on from here. So you can take over from here. At this point in time, allow me to do what my mama taught me. A good visitor knows when to leave, or mama would say a good dancer knows when to leave the dance floor. So till we meet again, be rest assured at JTS Maths Tutoring, we are committed to keeping you mathematically informed. Adios, amigas and amigos. See you soon.